Thank you very much. My name is Tanir. I'm an associate professor at TU Eindhoven in an intelligent systems group. We are called Interconnected Resource-Aware Intelligent Systems. A lot of my colleagues are in the back there. My work specific to embedded AI is mainly focusing on IoT intelligence, resource-aware IoT intelligence. And I have several, several interests in there. First one you could call resource-constrained embedded AI or resource-constrained edge AI, where I'm looking into trade-offs between model complexity, there it says model size, but maybe we should say model complexity versus performance of models in unseen data. Then I'm looking into distributed AI. Then you have concepts like federated split learning and so on. And there I look into, again, similar trade-offs between distribution of the model, how well can we distribute it so that it becomes manageable in terms of resources for all the nodes, but then that creates communication overhead. That means that we have some trade-off between distribution and performance and resource efficiency and also privacy. And I'm also very much interested in the joint design and development of communication infrastructure together with the intelligence itself. So then we're looking into wireless communication for edge systems, edge intelligence. And again, there are similar trade-offs between then you have the system architecture. Their architecture is referring to the system architecture, network architecture, and protocol complexity for communication. Then again, versus cost of communication. Cost of communication can be in any form in terms of packet traffic in the network, but also you can think of the resources of the devices themselves in terms of energy and compute power. And then performance of the models again. So in each of these cases, performance refers to performance of the AI model. When you work with IoT systems, you get very accustomed that there's an abundance of resources that are, the abundance of data that are unlabeled and in deployment locations. So you can collect lots of data, but there is actually there's a scarcity of labeled samples. So it's very rare that you get labels for it. That means we need to look into ways to deal with it, and I look into unsupervised learning, self-supervised learning, transfer learning strategies for that. And finally, dealing with distribution shifts. Of course, you can think of distribution shifts in terms of generalizability, but I also look into distribution shifts after deployment, which means we look into techniques like continual learning in my research. So we were involved in many European and local projects, and I'd be happy to talk to you about all of these things if you find me later. Thanks.
Thank you.